In the diagram, O is the center of a circle with radius 87. P and M lie on the circle. N is positioned inside the circle so that Pn passes through O and is perpendicular to Mn. If Mn is 63, what is the area of triangle PMN? Okay, let's label this. The radius is 87, so that is 87 MO, and OP is also 87. And then MN is 63, like that. And what are they asking? Area of PMN, so the full. Okay, so first I got to figure out NO. So using Pythagoras, NO squared plus 63 squared is 87 squared. Right? And you can solve this, and when you do, you'll get NO equal to 60. So let's put that in there. That's 60. So the area of triangle PMN would be 1/2 base times height. The base is 60 plus 87, and the height is 63. And that's it. And when you crunch out these numbers, you get 4630.5. Therefore, number 21 is D. It took Nasreen 2 hours and 30 minutes to canoe the 4.5 kilometers into her camp, paddling much faster. The return trip took her 1/3 of the time. What was Nasreen's mean speed as she paddled to camp and back? Okay, so speed is equal to distance over time, as always. And I guess we have to do this twice. We have to do it for when she's going there and when she's coming back. So when she's going there, her time is 2.5, right, in hours, and her distance is 4.5. And then when she's coming back, the time is 1/3 of that, so 2.5 divided by 3, and the distance is the same because it's coming back the same way. So the overall speed, or the average speed, would be distance over time. So first we have to add up both distances, 4.5 plus 4.5, and then divide by the two speeds. So it's divide by the 2 times. 2.5 plus 2.5 over 3. And you guys can crunch out these numbers, and when you do, you get approximately 2.7, I believe. So number 22, the answer is E. Each of the 2 cylinders sit on one of their circular faces on a flat surface. So cylinder A with radius 6, height 50, which is empty, and cylinder B with radius 8 and height 50, which is full of water. After pouring some of the water from cylinder B into cylinder A, the height of the water in both cylinders is the same. What is the height of that water? Okay. So let's see here if I can draw a diagram. So we got the first one, and the second one is slightly bigger radii, like this, I guess, something like that. And both of them have 50, and that's 6, and that's 8, I believe, right? According to the question. Yeah, and that's also 50. Okay, so initially you have all this water, and then you're pouring it, and then when you pour it, they're going to have the same height. Now, we're not told how much is poured in, but we can figure out the total volume of the water because initially this cylinder B was full. So when it was full, and they even give you that volume formula, it's nice of them, pi r squared h. So pi r was 8 and h is 50. So that initial volume was 3,200. 3,200 pi. And then now they want these heights, so I'll just call it h, and the heights are the same, so both are h. And then from this guy, the volume is pi r squared, which is 6 squared h, and this guy is pi r squared, which is 8 squared times h. Now when you add these, they've got a total that 3,200 pi. Got it? Okay, so let's see here. The pi's cancel from everything, so this is just going to be 36h plus 64h, and that's going to be 3,200. And then that's 100h is 3,200, and therefore h is 32. And that means 23 would be C. (24) The number of pairs of integers a and b with a less than b and a plus b less than 100 satisfy the equation A over 4 plus B over 10 is 7 is. All right, so let's see here. Let's modify this formula first. Let's get a common denominator. So 4, 4, 10, and 10. So it'll be 10A plus 4B is 7 times 40, which is 280. And then let's isolate for one of them. So if I isolate for B, it would be 280 minus 10A all over 4, right? Yeah, okay. So I'll use this to make a little table. And I'm not sure. They just say integers. They don't say if it's positive or negative. Interesting. So I guess there's positive and negative possibilities, which just makes it more time consuming, but that's okay. Okay. First, I'll do the positive ones, and then I'll see what I can do if there's any negatives. So we got to, hopefully it's not too long. The answer choices don't seem that big. The biggest being 20, so I guess the most I have to calculate is 20 such pairs. Now the parameters, A has to be less than B, and A plus B has to be less than 100. Okay, so we got to make sure we stay within those parameters. Okay, so let's start with 1, since that's the smallest integer that's positive. And then we'll go into the, 0 and less, I guess, on the other, in the other table that I make later on. Okay, so here we go. So remember, I'm using this formula right here. So when A is 1, this becomes 67.5. And then when A is 2, we get 65. When A is 3, we get 62.5. When A is 4, we get 60. Now, I very quickly can realize that you're only going to get integer values when A is even. So let's just only do the even ones, right? That makes sense, I hope. So we get 6, 8, 10, 12, 14, 16, let's see here, 18, and 20, 22, and so on. So let's fill this in. Okay, let's see here. So we're going to have, I think this is going down by 5s, right? So it'll be 55, 50. So you can do this pretty quickly. 45, 40, 35, 30, 25, 20, 15. Okay, so wait a second here. Right here is where we need to stop, because A has to be less than B, right? Because if it's 20, 20, then A is equal to B. And if it's 22 and 15, then A is greater than B. Okay, so, and we got to make sure that this is satisfied, that A plus B is less than 100, this guy. And I think they're all less than 100. Yeah, if you look at this, this would be 67, this would be 64, 60. They're actually going down. So I don't think any of them will be greater than 100. So let's see how many we got. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 9. Okay. Interestingly, 9 is one of the answers, but wait, we don't circle that yet. We got to go through this whole thing again, but now going 0 and below. So let's start off with 0, and we get 70. Remember, I'm using this formula, in case you forgot. Negative 1, we're going to get 72.5. Negative 2, you get 75. Okay, so it's the same kind of story where you're only going to get integer values for B when A is even. So let's just stick to the evens. Minus 4, minus 6, minus 8, and that whole big long song and dance. Minus 12, minus 14, minus 16, minus 18, and so on. Minus 20. You guys get the point. Okay, and then calculating these values will be fairly straightforward, because I believe it just goes up by 5 this time, each time. So for example, negative 4 would be 80. Negative 6 would give 85. 90, 95. Negative 12 would give 100. 105. 110. 115. 120. Okay, and now at this point we need to stop. Why? Because remember, A plus B has to be less than 100. And for this guy, this pair, A plus B looks like it is exactly 100. So we can't use that one, but we can use all the other ones. And let's see which one, how many we got. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we got 10 here. So We have 9 here, 10 here. We have to add those up. And when you do, you get 19. So the answer to 24 is B. Given the list 2, 3, 4, 5, there are exactly 3 different ways to choose the 3 integers from the list and form a triangle whose side lengths are equal to these integers. The integers chosen could be 2, 3, 4, 2, 4, 5, or 3, 4, 5. The integers 2, 3, 5 cannot be used as the sides of a triangle. Given the list 4, 10, 3, n, and 13, there are exactly 4 different ways to choose 3 integers from the list and form a triangle whose side lengths are equal to those integers. If n is different from all the other numbers in the list, then the sum of all possible values of n is. All right, so in the world of triangles, if we were to label this A, B, and C, we have to abide by a rule known as the triangle inequality. And what that states is that the largest side has to be less than the sum of the other two. So like that. So A plus B has to be greater than C. So that's why 2, 3, 5 cannot be used as a triangle, because 2 plus 3 is actually equal to 5. It's not greater than 5. So that triangle inequality fails for 2, 3, 5. Okay, so now what they've done is they've given us another list, and that list is 4, 10, 3, n, and 13. And they're saying from that list, you have to form exactly 4 different groups of 3s. So 1, 2, 3, that's one group, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And each of these groups, you're able to make a triangle legitimately obeying the triangle inequality. Got it? Okay, so let's see here. Without talking about n first, let's just talk about the other numbers. Can we make a triangle from 4, 10, 3, and 13? And I think the 3, the 10, and the 13 cannot. That will fail the triangle inequality. But 3, 4, and anything? 3, 4, and 10 won't work. 3, 4, and 13 won't work. 4, 10, and 13, I believe that will work. 4, 10, and 13. Yeah, that will obey the triangle inequality because 4 plus 10 is indeed greater than 13. Okay, great. So now they're saying you got to find 3 more such, but obviously all of the other ones have to have an n in there. Yeah, like this. Because the 4, the 10, the 3, and the 13, this is the only one that works based on what I just discussed. Okay, all right. All right, so I guess that's where I'm headed next. Okay, so let's work with this now. So for each of these, I've got to have an n and then 2 other numbers. So what are my possibilities? I could have n, 3, and 4. I could have n, let's see here, 3 and 10. I could have n. I'm choosing, of course, from up here, right? What else can I have? N, 3, and 13. N, 4, and 10. N, 4, and 13. And N, 10, and 13. Does that cover everything? I think so. Okay, so now for each of these, I've got to figure out what is n. All right, so let's take this one step at a time, and hopefully after a few of these you will be able to get the hang of it, and I won't have to walk you through every single one. I'll walk you through a few of these, and then I'll let you guys do the remaining. So I'll do the first one. I'll do the first 2, let's say. Okay, so we have to figure out what is n, right? In order to make a triangle with that triangle inequality. Now, the triangle inequality states that 2 sides have to be greater than the last side if the last side is the biggest side. So this one would give me that n has to be less than 7. Yeah. But it can be rearranged in some way that n plus 3 could also be used as part of the triangle inequality, and that's going to be greater than 4. So that means n has to be greater than 1. Okay, so n has to be greater than 1 and less than 7. So that means n is going to be either 2, 3, 4, 5, or 6, right? But remember, n cannot be the same as any of these guys up here. So it can't be this 3. It can't be this 4. And therefore, the only ones it can be is 2, 5, and 6. Got it? Okay. Now, we're still not done with the question. We got to first find out all the possible n's, and then we got to discuss the next component to the question. But this is how you figure out the n's. I'll do one more. The next one, same thing, using triangle inequality. 3 plus 10 has to be greater than n, and therefore n looks like it's less than 13 there. But also, you can use that n plus 3 has to be greater than 13, and that gives me that n is greater than 10. Okay, so that means, wait, hold on, did I do this right? Sorry, that should have been a 10 right here. Sorry. I don't know where I got the 13 from. So n has got to be greater than 7. Okay. So that means n is greater than 7 and less than 13. So n is either 8, 9, 10, 11, or 12. Now, remember, I think 10 is already up there, so this can't be a 10. So it can be either an 8, a 9, an 11, or a 12. Got it? And you guys get the point. So I'm not going to manually walk you through the last 4. I'm just going to list the n's. So doing the same process for the next one, you're going to get n for the next one as either 11, 12, 14, 15. And for this one is 7, 8, 9, 11, 12. And for this guy is 11, 12, 14, 15, 16. And this one has a lot of n's. This one is 5, 6, 7, 8, 9. And then you skip the 10, 11, 12. Skip the 13 because you can't have two numbers twice. 15, 16, 17, 18, 19, 20, 21, and 22 actually. So a lot of n's. Okay. Okay, so now that you have figured that out, now we get to the last part of the question. And the last part of the question basically has to figure out that were you able to get 4 sets? Remember, we wanted 4 sets, right? So here was set number 1. We need to get 3 more sets. Exactly 4 sets. So if some of these n's give you only 1 set or 2 set, or if they give you 3 sets or 5 sets or 6 sets, those are no good. We have to have exactly 4 sets. Okay. So let's see what we can get here. Okay. So let's make a list of the table here. We have n, and then we've got the first set, the 3, 4, n. This is up here. And then we have, I'm just going to put them in 3, 10, n, 3, 13, n. What's the next one here? 3, 4, n, 3, 10, n, 3, 13, n, 4, 13, n. Let's see here. Well, let me put this in order actually. 4, 10, n. Yeah, 4, 10, n. And then 4, 13, n. And then 10, 13, n. Gonna need a little bit more space. And then what's the next one? 10, 13n, and then finally 4, 10, and 13. That's the one I think that I made without the n, right? Without the n. And then number of triangles. And we want the number of triangles to be exactly 4, correct? Yeah. Okay. Let's see what we get. So, let's see what happens here. Hopefully, this all makes sense. Okay. So, we have a lot of n's, right? And the n's vary anywhere from, I believe, 2 all the way until 22. 2 is the smallest right up there, and 22 is the biggest. And of course, we're omitting values 3, 4, 10, and 13 because those have already been included and those cannot be repeated and cannot be the same as that. Okay, so it's a long list, but the good news is that when n is less than 7, you will never be able to get all four triangles to fulfill the triangle inequality. And I encourage you to figure out why. Because, for example, if n was, let's say, 2, and you substituted that into these guys, this one here, this one here, this one here, you would never be able to get 4 of them to satisfy the triangle inequality. And similarly for any other value less than 7. So 7 is the first time that you can get at least, I think at least 3 to satisfy the triangle inequality. And then values of 8, 9, remember n cannot be 10, 11, 12, it cannot be 13, 14, 15, 16. And then the good news is when n is greater than 17, greater than 16 actually, same story, is that these triangles will never be able to satisfy the triangle inequality more than twice. Like you'll only get it to satisfy 2 of them, and we want 4. And I encourage you to figure out why. Like if n was, let's say, 18, you wouldn't be able to make a triangle in a lot of these, except for maybe 2, and that's the maximum. So we want 4. Okay, so here we go. If n is 7, which ones will satisfy the triangle inequality? I'll just put a check mark there and there. Well, this one is this is already a pre-made triangle, so this was always going to be satisfactory. So I can just put a check mark there for everything, because that's already made. So this is check marks all down the board. Okay, so now, how many of these, with n being 7, has satisfied the triangle inequality? And the answer here is 3. Just this one, and this one. Well, that's not what we want. We want 4. Okay, so you just keep going. When n is 8, how many will be able to satisfy the triangle inequality? And it's this one, this one, this one, and this one. So this gives you 4. So this is a value of n that is acceptable for us. And you keep going like this. For 9, it's this, 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 and this. So that's 4 again. For 11, I believe it's 1, 2, 3, 4, 5, 6. So that's 6. So that's too many. We want exactly 4, not greater than 4. For 12, I believe it's the same 6. For 14, I think there's these 4, so that's good. We will include 14 as our n, a value of n. And then for 15, again, it's 4, I believe. So the 15 is included. And for 16, finally, I think we only get these 3. So that's a 3. Okay, great. So our values of n that are acceptable are 8, 9, 14, and 15. And we need to find the sum of those values. So 8 plus 9 plus 14 plus 15. And that is 46. So 46 is the answer to a very challenging question. Number 25, the answer is 8.